Okay, so we have talked about transmission of pressure through liquids, and then we have talked about pressure due to a compressed gas, and then we have talked about atmospheric pressure, and that is where we have stopped. So today we have to talk about upthrust, right? So all of you can hear me, right? Just to double check. Give me a thumbs up if you can hear me. Okay. All right. So we are moving on to the last part of pressure. Okay. Abhi atmospheric pressure wala, we were talking about mercury barometer kata kara. We have a little bit more because we didn't talk about we talked about the pressure, right? Okay, hari hari. So we have a little bit more to talk about because last week we finished talking everything about the mercury barometer, right? I think that is where we stopped. Mother whiteboard note open crystal. I think that is where we stopped, right? Is that right? Is that where we stopped? We talked about the mercury barometer and then we wrote a few sentences and that's where we stopped, right? Can you double check and let? Yeah. Okay. So now, I hope you remember what we talked about in the mercury barometer. It's a pretty useful equipment, a pretty useful apparatus, right? Because wherever we go, if we can set up a mercury barometer, we can get a reading about the atmospheric pressure, right? අන්තික හරි ලේසිත් එක්ක P equals H rho G දාලා ගත්තාම අපිට කොහොමද atmospheric pressure එනවා. අර අපි මං කිව්වේ square කරගන්න කියලා. Atmospheric pressure is also H rho G. So rho is density, G is gravitational acceleration, H is the height of the mercury column in that tube. Okay. So, but there's a problem. එකක් තමයි දැන් හිතන්න ඔයගොල්ලන් පිදුරු තලාගල නගිනවා, right? පිදුරු තලාගල is the tallest mountain in Sri Lanka, right? And you want to measure the atmospheric pressure. Imagine climbing Pidru Talagala and setting up a mercury barometer there. Do you think it would be like an easy thing or a difficult thing to do? Would it be an easy thing or a difficult thing to do? Alama? What do you think? Yeah, quickly. Would climbing to Pidru Talagala and setting up a mercury barometer, would that be easy or difficult? Okay, others?
Difficult?
It is obviously difficult, yes. Yes. Because බලන්න ඒකේ අර tube එක 1 meter tube එකක් අපි ගන්න ඕනේ. So ඒක කරටම පිරෙන්න mercury we have to fill and then we have to flip it and we have to immerse it in a container with mercury. So we have to use a lot of mercury also and it's not a very stable structure. It's quite difficult to set up, right? And that's one thing. It's not very easy to use. The other thing is that my mercury is not good, right? Mercury, when it comes to contact with the skin, it causes cancer. We call it carcinogenic. So because of these two reasons, mainly because it's very difficult to use and all that, now the technology has improved later and yes, Sasheli.
Miss, if mercury is dangerous, why do we use it in a thermometer?
Now actually mercury thermometers are very less used. So back in the days, mercury thermometer was used. හැබැයි mercury thermometer ke glass bulb එක ඇතුළේනේ mercury තියෙන්නේ. So that also it's not coming out. So it's not coming into contact with the human skin or like අපි දැන් කටට දාලා උණ බැලුවත් කනට දාලා උණ බැලුවත් කොහොම උණ බැලුවත් අර the mercury is inside the tube. So then it's not dangerous. But the problem is even when we're using these thermometers, හිතන්න ගෙදරදී thermometer එකක් කැඩුනා කියලා. I have actually touched mercury. එහෙම thermometer එකක් කැඩිලා එහෙම වුණාම ළමයි හිමුක අල්ලනවා. Right? Because mercury drops are a little හරි මේක අර අපි නොදැන එක ඇල්ලුවම it's kind of like it's a little fun. Bubbles කැඩෙනවා. I don't know if you have really seen mercury in real life. That's how it is. But later තමයි වැඩිපුර ඒ ගැන awareness එක ආවේ. ඒකත් එක්ක දැන් ගොඩක් thermometers use කරන digital thermometers, right? And also there's some thermometer called glass alcohol thermometer. mercury වෙනකොට alcohol use කරලා තියෙන එකේ. ඒක හරිය digital thermometer එක හරිය තමයි use කරන්නේ. About like until like 10 years ago වගේ thermometers ඔක්කොම mercury එක තමයි use කරේ. People knew but thermometer එක උනත් ඇතුලේ තියෙන හින්දා අවුලක් නැහැ නේ කියලා හිතුවා. But then it could break and there could be many other complications. So then I think it was මම දැන් ඒක law එකක් විදිහට ගියාද කියලා but schools වලටම advice කරලා තිබ්බා universities වලට advice කරලා තිබ්බා unless it is absolutely essential not to use mercury. Right? එතකොට ගොඩක් එහෙම ඊපස්සේ hospitals වල උනත් එහෙමයි. So they're using digital thermometer mostly. So yes, this is a carcinogenic and it's also very, very difficult to set up. So ekhinda later a new barometer evolved or a new barometer was discovered or invented. It's called aneroid barometer, right? මේක අපි diagram එකක් අඳින්න ඕනෙත් නැහැ. මේක diagram එක අහන්න නැහැ exam එකට. But to explain, I will use this diagram that is on the textbook. And all right. So here, this is an aneroid barometer. මෙතන mercury අපි use කරන්නේ නැහැ. මෙතන අපි use කරන්නේ air විතරයි. We are using air. Air වලින් කිසිම damage එකක් නැහැ, කිසිම harmful ගතියක් නැහැ. And it counts as one machine or like one equipment. ඒතර එක හැරම හැට carry කරන්නත් ලේසි. So මෙතන වෙන්නේ something like very simply. මේක ලොකුවට දැනගන්න ඕනේ. Simplyම දැනගත්තත් හිතන්න if we go to the sea level, right? Sea level ගත්තාම above sea level, the atmospheric air column height is much higher. So at the sea level, atmospheric pressure is higher. Atmospheric pressure high කියන්නේ මොකද air වලින් ලොකු pressure එකක් එනවා. Because atmospheric pressure is higher, මෙන්න මේතන තියෙනවා පොඩි cavity එකක්. මෙන්න මේ cavity එක thin metals වලින් තමයි metal එකකින් තමයි හදලා තියෙන්නේ. ඒ කියන්නේ මේක ඇතුලේ මුකුත් නැහැ. ඇතුලේ තියෙන්නේ just vacuum. එළියේ මේ cover එක හදලා තියෙන්නේ thin metal එකකින්. So it's a cavity. So when the atmospheric pressure is high, what happens is that pressure එක එළියෙන් වැඩිනේ. atmospheric pressure එක වැඩි. So ඔක්කොම වටේ තියෙන air particles ටික මේ cavity එකට එළියෙන් press කරනවා. Because atmospheric pressure is high. Because of the high pressure. So they will apply a force to the cavity like that. So because of that, the cavity will feel a force from all around the atmosphere. Right? ඒතර යාව නිකන් තද වෙනවා. Right? එතකොට අන්න ඒ sense එක මෙන්න මෙතනට ගිහිල්ලා මෙන්න මෙතනින් connect වෙලා මෙතනට ගිහිල්ලා මෙහෙම connect වෙලා indicator එකේ reading එක පෙන්නනවා. So එතකොට මෙන්න මේ හරියට වගේ reading එක යනවා. Okay. But let's say at Mount Everest, the atmospheric pressure is very low, right? එතකොට මොකද කරන්නේ? The atmospheric particles, air particles in the atmosphere will not press that hard to the cavity. මේ cavity එකට හැම ලොකුවට air pressure කරන්නේ නැහැ. atmospheric pressure එක අඩුයිනේ. එතකොට අඩු වෙන්නේ pressure එක දැනෙන්නේ. So ඒක මෙන්න මේක through ගිහිල්ලා මේ indicator එක මේ හරියට විතර move වෙනවා scale එකේ. That means that pressure is low කියන එක. So that is how we get the reading from an aneroid barometer. Whatever the pressure is, depending on the pressure, the cavity will feel the pressure, high pressure or low pressure. Depending on that, the reading will go to the indicator. The indicator will move along the scale to give you the reading. එහෙම තමයි aneroid barometer එක හදලා තියෙන්නේ. So this is, as I said, much easier to use because it comes as one equipment. So our mercury setup එක වගේ හදන්න ඕනේ. It's quite easy to use. Secondly, we don't use mercury, so it's not harmful. Okay. Is this clear, Lamai? Others? Okay. So make a draw crown over there. Just write this. You don't have to draw, just write. Okay, so we're talking about the aneroid barometer, right? So एक अपनी हम ये बताऊं 40 points देखा. Quickly write these 4 points, Namai. Okay, ළමයි done. Done writing? Yes or no? Give me a thumbs up if you have finished. Can you all hear me, ළමයි? Give me a thumbs up if you can hear me, first of all. Okay, did you finish writing? This is a simple question. If you finished, you give a thumbs up. If not, you say no. Did you finish writing this, ළමයි? What about others? Senudi, Sasheli, Anya, have you all finished writing?
Done, teacher.
Okay. See, that's a simple response. Why can't you even give that one? All right. So this is the aneroid barometer. Then finally, we are going to be talking about applications of atmospheric pressure in daily life, right? So, okay, so the first application is drinking water from a straw, right? So I will show you what happens exactly when we are drinking water through a straw, right? So let's say this is the cup. This is the cup and it's filled with water, and then this is the straw. Like that, right? So this is where we are drinking water from. Okay. Now, what happens here, before you drink water from the straw, inside the straw, here there is atmosphere. Here, inside the straw also there is air, මෙතන කොහොමද තියෙන්නේ water, and outside also there is air. Inside is air, outside is air, so no problem. But when we are drinking water from a straw, Mama mulimma, when I'm sucking through the straw, first of all, I'm inhaling all the air particles inside. මේක ඇතුළේ තියෙන air particles ටික තමයි මම මුලින්ම මේ කටට ගන්නෙ. So when all the air particles in the straw goes into my mouth, what do we have inside here? When I'm sucking through a straw, before I take in the liquid, I take the air particles, right? So when I take the air particles inside the straw to my mouth, what is inside the straw? There's nothing. Air particles are not there, right? If I consider this point, I'll say that that point is A and this point is B. When I'm trying to drink through the straw, as I said, when I'm sucking, first of all, I'm taking the air particles inside the straw to my mouth. So once I take the air particles, make ඇතුළේ air particles නෑ. Right? So my question is, when that happens, is the pressure at A or B higher? A වල pressure එකද වැඩි, B වල pressure එකද වැඩි? Yes.
A.
Okay. Others? Others, what do you all think? So, Balanna, now all the air particles inside the straw I have taken in. Then මෙතන air නැහැ. But මෙතන එළි air තියෙනවා. Atmosphere තියෙනවා. So B is feeling atmospheric pressure, but A is not feeling the atmospheric pressure. So එතකොට actually pressure at B is higher than pressure at A. B වල pressure එක A වලට වඩා වැඩි because එළියේ atmospheric pressure is there. So atmosphere is pushing this water surface down. But straw එක ඇතුලේ එහෙම මුකුත් නැහැ because inside straw එක ඇතුලේ තිබේ air particles ටිකත් මම කටට ගත්තා. So what will happen is that since in the outside air is pushing the liquid surface down, මෙතන pressure එක අඩු වෙච්ච හැටියේ මේ ඇතුලේ තියෙන liquid එක මෙහෙම උඩට යනවා to fill this space. Because මෙතන pressure එක අඩුයි. හැම වෙලෙම everything always moves from high pressure to low pressure. So that is how all the liquid flows through the straw and into our mouth. Because initially we are what we are taking is the air particles inside the straw only we are taking into our mouth. Did you understand that, Laman? Did you understand that? Others? All right, so let's write that down. Diagram එක කැමති නම් අඳ ගන්න නැත්නම් ඕන නැහැ because the as long as you understand the concept that is enough. Drinking water from a straw. Okay. So quickly write this, Laman. Okay, Lavan. Now, the second application is something called the siphon method. Okay. For this, I will take the same image as on the textbook and I will explain it like that. Then siphon method එක මොකටද අපි use කරන්නේ? Okay. So now let's say there is a tank somewhere higher. ඔයාලට උස තැනක there's a tank. ඒ tank එකේ වතුර ටික මට පල්ලෙහාට ගෙන්න ගන්න ඕනේ. Okay. So for that, I can use a siphon method. Okay. Siphon method එකේ මුලින්ම කරන්න ළමයි. Now දැන් උඩ tank එක තියෙනවා. මේ tank එක fill කරලා තියෙන තැනක. Actually, rather than using a textbook image, I will draw an image because I just want to show you something. මේ තමයි උඩ tank එක. So ඒකේ already දැන් වතුර හරි මොන හරි fill කරලා තියෙනවා. දැන් මෙතන තියෙනවා පල්ලෙහා තියෙන tank එක. So I want to bring this water down. Okay. Here what I'm first going to do is I'm going to take a tube, right? මෙන්න මේ වගේ තියෙන tube එකක් මම ගන්නවා. Like, sorry, that doesn't look very nice. A tube like this. Let's say this liquid here is water. අතන එතන liquid එක water නම් මම මේ tube එක තනිකර water වලින් fill කරන්න ඕනේ. fill කරලා දෙපැත්තේ මේ corners දෙක මම වහනවා. Otherwise වතුර ටික හැලෙනවානේ. දෙපැත්තේ corners දෙක මම වහනවා. So this entire thing is filled with water and දෙපැත්තේ corners දෙක වහලා what I'm going to do is I take this setup and I arrange it like this. Once I arrange it, what I do is මේ දෙපැත්තේ වහපු දෙක open කරනවා. එතකොට මොකද වෙන්නේ? මේකේ තියෙන water ටික මෙහෙම මේක තුරු ඇවිල්ලා වැටෙන්න පටන් ගන්නවා. So මොකක්ද එතන වෙන්නේ? කොහොමද නිකන් මෙහෙම water වැටෙන්න පටන් ගන්නේ? So what happens here is if you take then here water starts to flow from here, right? If I take this point as A A වල pressure එක වට බලන්න පුළුවන්. දැන් හිතන්න මේ tube එක ඇතුලේ බලද්දී අමාරුයිනේ. If you take a point at the same level, let's say මෙන්න මෙතන මේ x කියන point එක ගමු. A වලයි x වලයි pressure එක equal, right? Because A and x are points at the same level. So what is the pressure that x is feeling? x එනවා මෙතන atmosphere එකේ තියෙන pressure එකක් එනවා. ඊට අමතරව here liquid column එකේ එන pressure එකත් එයාට එනවා. So if x is feeling atmospheric pressure plus the pressure of the liquid column, and we know pressure at x is equal to pressure at A. So A is also feeling the same pressure. Okay? Atmospheric pressure plus the liquid column pressure. So එහෙනම් I can say pressure at A is atmospheric pressure. One second. Atmospheric pressure plus pressure due to liquid column. කොහොමද මම ගත්තේ? Let me tell you again. A වල මට ගන්න ටිකක් පැටලෙනවා. මොකද මෙතන ටියුබ් එකක් තියෙනවා. ටියුබ් එකේ වතුර ඉස්සලා තිබ්බා. So A වල pressure එක ගන්න මට පැටලෙනවා. හැබැයි මම දන්නවා එක liquid එකක same level එකේ pressure එක equal. So what I do is A ට එක level එකේ තියෙන වෙන point එකක් මම ගන්නවා. Like for an example, here this point is X. And I take the pressure of X. So X එනවා මේ liquid column එකේ pressure එක එනවා නේ. යාට H rho G දාලා we can find that. Plus there's atmosphere also. So atmospheric pressure also X is feeling. So whatever pressure X is getting, that is the same pressure as what is A is getting because they are the same level. So here now pressure at A is atmospheric pressure plus pressure due to liquid column. Is that clear, Lama? Give me a thumbs up. Is that clear? Others?
Can you explain again, please?
Yes. So listen very carefully. So here, if you take A, ඒවල pressure එක මට එකපාරට ගන්න අමාරුයි තේරෙන්නේ නැහැ. මොකද මෙතන tube එකක් තියෙනවා. There's water. It's confusing. So I take a point at the same level as A in the same liquid, right? So A ට එකම level එකේ තියෙන තව point එක ගත්තොත් let's say this is X. X ට එන pressure එක මොකද්ද? We know above X there's a liquid column no. So මෙතන liquid වල pressure එක එනවා. In addition to that, above that there is atmosphere. So X is also feeling the atmospheric pressure. So pressure at X is atmospheric pressure plus pressure due to liquid column. And we know pressure at X is equal to pressure at A because they are the same level. In a pressure at X කියන්නේ atmospheric pressure plus pressure due to liquid column now. Pressure at A is also the same thing. That is atmospheric pressure plus pressure due to a liquid column. Is that clear, Sashili?
Yes, thank you.
Okay. So then if you take this point B, B වලත් මට එකපාරට පැටලෙනවා කොහොමද ප්‍රෙෂර් ගන්න කියලා. මොකද අර ටියුබ් එකක් තියෙනවා ඒකේ මර්කරි සොරිමකනේ වෝටර් තියෙනවා. එතකොට ළමයාට මම කිව්වා නේද pressure at the same level of a liquid is the same කියලා. So something about that is that not only liquids actually air වලත් ඒකම තමයි. atmosphere එකෙත් එකම level එකේ atmospheric pressure එකම level එකේ ළඟ points දෙකක් නම් atmospheric pressure is the same. So since I don't understand how to get the pressure at B, මම A level එකේ මින වෙන point එකක් consider කරනවා. Like this point Y. Y ට උඩින් liquids මුකුත් නැහැනේ sir. The only pressure Y is feeling is atmospheric pressure. Y ට තියෙන atmosphere එකේ random point එකක්. So it's only getting atmospheric pressure. Since pressure at Y is equal to pressure at B, B is also only getting atmospheric pressure. එහෙනම් pressure at B is atmospheric pressure. So now tell me pressure at A or pressure at B is higher. A වල pressure එකද වැඩි B වල pressure එකද වැඩි?
A.
I think others also must have noticed that, correct? That is A. Because A is getting atmospheric pressure plus pressure due to liquid column. B is only getting atmospheric pressure. So pressure at A is greater than pressure at B. And I told you whenever, whatever it is, things always go from high pressure to low pressure. Therefore, liquid will go from A to B. And then මෙතනින් මෙහෙම වැටෙනවා. Okay, that is the siphon method. Is this clear to you, ළමයි? Is this clear? Okay. So let's write a few points. Just use this straight away here. Quickly write this. Make it a little better to like draw a sketch of the diagram. I think it will be easier for you later also when you're referring to it, right? At the pattern, so draw a little diagram. Quickly write. Done, Lamai? Did y'all finish writing? Give me a thumbs up if you have finished. All right, great. Then lastly, we have to talk about the rubber sucker, right? Have you all seen a rubber sucker before? නම කිව්වම සමහරට ඔයගොල්ලන් එකපාරට click වෙන්නේ නැතුව ඇති, but let me show you a picture quickly. I'm talking about this. So I hope you can see on the whiteboard I have added a picture. So do you all know this? Rubber sucker, do you all know this? අර මෙහෙම බිත්තියට හයියෙන් ගැහුවම එක ගිහලා බිත්තිය ඇලෙන්නේ. Do you all know this? No? Give me a thumbs up if you have seen. Yeah. Okay. Now here also what happens is it's atmospheric pressure. එතන වෙන්නේ අපි හිතමු ඔන්න මොකද smooth surface එකක් තියෙනවා. Let's say this is like a glass ball. So this is the rubber sucker. Now what I do is ළමයි මම මේක හිමින් ගෙනල්ලා මෙහෙම glass ball එකකට තිබ්බොත් මෙයා මෙහෙම glass ball එකේ ඇලවෙනවද? Will it stick to the glass ball? If I just bring it very slowly and then just keep it like this, will it stick to the glass ball? You tell me. What do you think? Based on your experience, tell me. No. Rubber sucker එකක් මෙහෙම හිමින් සැරේ slowly ගෙනල්ලා මෙහෙම බිත්තිය තිබ්බා කියලා ඇලවෙන්නේ නැහැ. No. So what you have to do is you have to bring it a little fast. Okay, ඉක්මනට මෙහෙම ගෙනල්ලා බිත්තිය ඇලවුවාම තමයි ටක් ගාලා ඇලවෙන්නේ. What really happens is ළමයි when you quickly move it like this, right? You're quickly moving it like this. What happens is දැන් මෙතන තියෙන air particles තියෙනවනේ. ඔයා මේ high move කරද්දී මේ ඇතුලේ තියෙන air particles එළියට move වෙනවා. Because you're moving it very fast towards the glass ball. So all the air particles inside will move out. Not all, but most of the air particles inside will move out. Then what will happen is that when this sticks, දැන් මෙයා මෙතන stick වෙනවනේ. මම හයියෙන් ගෙනල්ලා අරගෙන ඇවිල්ලා මෙයාව stick කරනවා. Stick කරාම now what has happened is some of the air particles inside has moved out. So එතකොට ඇතුලේ pressure එක අඩු වෙනවා. But what about outside? Outside it's still atmospheric pressure. Outside it's still atmospheric pressure. So outside pressure එක වැඩි, ඇතුලේ pressure එක අඩුයි. Okay? So pressure outside is greater than pressure inside. So because of that, what will happen is the atmospheric pressure will keep pushing the rubber sucker towards the wall. එළිය pressure එක වැඩිනේ, so එළියෙන් ඇතුලට මෙහෙම push කරනවා. ඇයි එහෙම උනේ? Let me tell you again. Listen very carefully. There is a wall. Rubber sucker එක හිමින් ගෙනල්ලා මෙහෙම තිබ්බට එයා paste වෙන්නේ නැහැ. Paste නෙවෙයි, sorry, stick වෙන්නේ නැහැ. But if I move it fast, what happens is the air particles inside between the rubber sucker and the glass wall quickly move out because I'm moving it fast. Then when I stick it, what happens is the inside pressure is low because most of the air particles have moved out. But outside pressure, it's the normal atmospheric pressure. So pressure outside is greater than pressure inside. So එළියෙන් ඇතුළට push කරලා තියන් ඉන්නවා glass wall එකට stick කරගෙන. That is what happens here. Is that clear, ළමයි? Is that clear? All right. Quickly write this. Make it put sketch එකක් අරගෙන I think it will be easier. Swiftly, fast, that means. Smooth surface, let's say. Quickly write, Lamai. Then we are moving to upthrust. Quickly write this. Okay, Lamai, done writing? Give me a thumbs up if you have finished. Others? All right. Okay, so we are moving to the last section of pressure, upthrust. And this is very, very important for you all to understand properly. Huh? So let's put a topic, upthrust. Upthrust. Okay. So if you have had a dip in a pool, or if you have had a dip in a lake or a waterfall, river, tank, whatever, in a big water body, or නැත්නම් නිකන් බේසමකට අත දාලා තියලා බලලා තියෙනවා නම්, do you feel that when you put your hand in the water, the alien atmosphere එකේ මෙහෙම අත මොකක්ද ලේසිනේ. But when you put your hand into water, do you feel that it's a little difficult for you to press your hand down? පාමක මෙහෙම වතුර ඇතුලේ මෙහෙම press කරන්න ටිකක් අමාරුයි කියලා දැනලා තියෙනවද? චූට්ටක් අමාරුයි කියලා. As if like වතුරෙන් වාට උඩට force එකක් දෙනවා වගේ. Have you all felt that? Have you all felt that? Yeah. So that is because water actually is giving a force upwards. Not only water, any liquid. හරිද? එතකොට ඒ කියන්නේ දැන් තව එකක් තමයි හිතන්න නිකන් ලොකු ලී කෑල්ල. right? ලී කෑල්ල කොහොම වතුරට දානවා. so ලී වතුරේ පා වෙනවනේ. ඔයා ඒ ලී කෑල්ල වතුර ඇතුලට press කරන්න හදද්දි ටිකක් අමාරුයි press කරන්න. because වතුරේ මෙහෙම උඩට force එකක් දෙනවා. That's why we call it up. Up means upward, thrust means force. So upward, then a force එක තමයි අපි upthrust කියලා කියන්නේ. So any liquid gives an upthrust. Don't write anything because I'm going to write a small sentence here later in the note. But before that, I will explain you what upthrust is. ඔන්න අපි මේක ටෙස්ට් කරලා බලන්න යන්න. So I have an object. Excuse me. Okay, so I have an object. මෙයා මෙහෙම hang කරලා තියෙනවා. I'm sorry that my background is a little dark because I'm actually not at home. I'm traveling for work, so I'm in Kandy. Actually, Sasha, you are in Kandy, right? Kandy where? Around where about in Kandy? Oh, okay. I'm not exactly sure where KCC is, but I didn't go there. I think I'm a little near the Kandy town. මං ඉන්න හරියට සීතා දේවී මොකක්ද කොලේජ් එක තියෙන්නේ අනේ හරිය ඒක චුට්ටක් එහා තමයි. Yeah, I mean that's like 5 or 10 minutes. Yeah. So that's where I'm staying today. So I think last 2 nights and 3 days wagem I was in Kandy. And tonight also I will be in Kandy. Tomorrow only I'm going to Colombo. So I'm not at home, so I can't really control the lighting much. So, oh, really? So you are near Casey's. Are you going to school near Kandy, around Kandy, or in Kandy? Because yesterday the place where I stayed, it was a pretty nice hotel, so I was able to like see yeah, I know Mahamaya because I have 2 cousins who went to Mahamaya from Kegol. So Mahamaya, right? And yesterday and the day before I stayed at a very nice hotel. ඒකේ හොඳ මේ උස තැනක තියෙන උස හරිය. So I don't know if you have heard of a place called Sunset Heaven or something. Yeah, it's very recent that they opened the hotel. So I had a very good view. I saw like Kingswood College. A ground එකේම හොඳට පෙවුනා, and I think I saw some like landmarks around Kandy. Anyways, Kandy is really beautiful. And I think it should be it's a good tourist attraction, no? Because most of the time when tourists travel, they mostly go to like down south ne godak down south එනවා. Yes, and නුවරඑළියේ පැත්තට යනවා. But Kandy නිකන් අර ගොඩක් pass by and pass කරන අතරේ visit කරන අරන්න Kandy වලටම කියලා ටිකක් එනවා අඩුයි compared to other locations. But එහෙම එන කට ඉන්නවා. But එනවා අඩුයි. So I feel like it should be a good touristy attraction because it's like the perfect balance, no? අර කොළඹ වගේ ලොකුවට රස්නෙකුත් නැහැ but නුවරඑළිය වගේ සීතලකුත් නැහැ. Very nice, like, you know, I feel like it's a nice balanced weather, and it's like oh, right. Still, I haven't heard, but yeah, Sita, sorry, Mahamaya එක මම දන්නවා කොතනද තියෙන්නේ කියලා. So then that means you're nearby, no? And also another thing I like about Kandy is that it's a very developed city, right? So city එක ගත්තොත් එහෙම හොඳට ඒ කියන්නේ හැම facility එකක්ම හොඳට තියෙනවා. But at the same time, චුට්ටක් city එකෙන් එළියට ගියපු ගමන් all the mountains, the scenery. Because in Colombo it's not the same. Colombo I think it's all city. Greenery කියන හොඳට greenery එහෙම තිබ්බට but මේ වගේ නිකන් mountains ලස්සනට view එක නැහැනේ. So it's just a city. And I also stay in Mathura a lot. Mathura city, of course, the ocean is there, but Mathura city is not as developed as Kandy. But the thing that I really love about Kandy is that the city is very developed, but at the same time, අරක්කොම් facilities ටිකක් තියෙනවා. චුට්ටක් එළියට ගියපු ගමන් you get the nice views, the scenery, the mountains, the lakes, whatnot. So it's really nice. Even the place I'm staying tonight, it has a very beautiful view. So yeah, I was just thinking today that at least once in my life I should come and live in Kandy for like 1 or 2 months because it's a really nice city. So yeah, I mean, I'm very jealous of you for living in a beautiful city, but others also, if you're around Kandy, I don't know, but if not, maybe you should travel and see around. I can Kandy ahama Dalda Maligaw විතරක්ම නෙවෙයිනේ තියෙන්නේ. Dalda Maligaw is the main attraction. But there are so many other places, no? මට ගොඩක් visit කරන්න බැරි වුණා, but I was just looking up like places. There are so many nice places in Kandy, like different landmarks and destinations that could be very nice touristy attractions. අපි වැඩිය වච්චර market වෙන ගොඩක් දල්දා මාලිගාවනේ යන්නේ. So yeah, it's really nice. 1 minute from Daldama. That's really nice. That's nice. මම දල්දා මාලිගාවට නම් මේ පාර ගියේ නැහැ. ගොඩක් ඒ කියන්නේ මම තනියෙන් හරි එහෙම යාළුවොත් එක්ක වගේනකොට දල්දා මාලිගාවට යවෙනවා අඩුයි. But when I'm coming with family, my mother is like very very devoted Buddhist. So if I come with my family, Dada Maligaw is a must. But yeah, overall, I give Kandy a 10 out of 10. It's nice. All right. So anyways, what I wanted to explain was that is why the setup is a little, dark and all. And connection is quite stable. But if it gets lagged, let me know. Okay, because I'm connected to a different Wi-Fi. I'm not very sure how strong it is. Okay. All right. So now on a spring balance එකකින් මම එල්ලලා තියෙන object එක. Okay. So let's say now when I'm hanging this object by a spring balance, මට ඒ object එකේ weight එක එනවා. අපි example එක විදිහට ගමු. ඔන්න මට මෙතන reading එක එනවා. Let's say 17 newtons. That means what is the weight of this object? That means what is the weight of this object?
17 newtons.
17 newtons, because that is what the spring balance is giving you, right? So now weight is 17 newtons, right? So weight can මෙන්න මෙහෙම තියෙන force එකනේ. So weight is 17 newtons. So what I'm going to do is look at what I'm doing here. මේ setup එක මම මෙහෙමම අරන් ගිහිල්ලා water, like a beaker with water. I take a beaker with water. මේ beak එකට මම මෙහෙම immerse කරනවා. And maybe immerse කරනවා. Now earlier it was outside water, now it's inside the water beaker. Now මට මෙතන reading එක එනවා 12 newtons. So that means, did the weight of the object change? Did the weight of the object change? So earlier it was 70 newtons. When I put into water, did the weight of the object change? What do you think? ළමයි object එක weight එකක් වෙනස් වෙන්නේ නැහැ නේ. So if you look at that earth එක ගත්තොත් එහෙම object එකේ weight එක වෙනස් වෙන්නේ නැහැ. So එහෙනම් weight එක නෙවෙයි වෙනස් වෙලා තියෙන්නේ. මොකද්ද වෙලා තියෙන්නේ? Now the weight is already anyways there. Right? Weight එක කොහොමද මෙතන තියෙනවා. In addition to weight, we have an extra force now. What is this extra force? Water වලින් object එකට දෙනවා මෙහෙම උඩ පැත්තට force එකක්. We call it upthrust. එතකොට ළමයි here I got 70 newtons, that was the weight. මෙතන 12 newtons එන්නේ weight එක තිබ්බර now there's an upthrust now. So එතකොට reading එක වෙනස් වෙලා තමයි එන්නේ. Okay. So here when it was outside water, right, when it was outside water, I got the reading as 17 newtons. ඒ කියන්නේ මේ object එකේ ඇත්තම weight එක 17 newtons. So I call it real weight. Real weight is 17 newtons. Metana, when I immerse this object into a container with water, I still get a reading. But that is not the actual weight of the object, because actual weight of the object is 17 newtons. මෙතන මට එන්නේ බොරු weight එකක්. මොකක්hari වෙනස් reading එකක් නෙන්නේ. ඒක වැරදි reading එකක්. ඒක බොරු reading එකක්. ඒ බොරු reading එකට මම කියනවා apparent weight. It's not real, it's just apparent. So ඒකට මම කියනවා apparent weight කියලා. Okay. So මේ apparent weight එක කොහොමද එන්නේ ළමයි? Apparent weight එක කොහොමද අඩු උනේ? Because apparent weight is calculated as real weight minus upthrust. Right? එතකොට the real weight එක අපි දන්නවා 17 newtons නේ. Real weight is 17 newtons. ඒකෙන් upthrust එක subtract වුණාම තමයි අපිට apparent weight එක එන්නේ. That is why the apparent weight is lower. Right? මේ යටට තියෙන weight real weight එක උඩට apparent weight එක. ඒකේ resultant එක නෙන්නේ. Right? යටට weight එක තියෙනවා උඩට upthrust තියෙනවා. So ඒ දෙනක resultant එක තමයි apparent weight විදියට එන්නේ. So if I rearrange this equation, this upthrust is minus here now. So I bring that upthrust to this side. Then it becomes plus. Equals real weight. Here the apparent weight is plus. When I bring it to other side, it becomes minus. So I get this. So this is quite important. Huh? This is quite important. So එතකොට now we can calculate upthrust. What is real weight? 17 newtons. What is apparent weight? 12 newtons. So 17 newtons minus 12 newtons, that is 5 newtons. So upthrust here is 5 newtons. Okay. So I'll explain it one more time again. Listen very carefully. When I hang an object to a spring balance outside, I get the real weight, actual weight again. So I call it the real weight and it's 17 newtons. Yeah, water at them, spring balance reading venas vela. So it's a different reading. So that's not the real weight now, because real weight is anyway 17 newtons. So that different reading, I call it apparent weight, because I know it's not real. එතකොට මම කොහොමද මේ reading එක වෙනස් වුනේ? එතකොට මට තේරෙනවා දැන් water වලින් උඩට force එකක් දෙනවානේ. Weight is downwards, but water is giving a force upwards. එතකොට we have to consider the result. එතකොට එතන weight එක විතරක් නෙවෙයි upthrust උත් තියෙනවා. There are two forces. I have to consider the result. So කොහොමද resultant එක ගන්නෙ? Weight එකෙන් upthrust අඩු කරනවා. So real weight minus upthrust, I get the resultant, and that resultant only is apparent weight. ඒකයි මේ අඩු උනේ. I make a real weight එකෙන් upthrust එක subtract කරනවානේ. Real weight was 17 newtons. එකෙන් upthrust subtract වුණාම තමයි apparent weight එන්නේ. So when I rearrange this equation, here upthrust is minus, I bring to this side, it becomes plus. Here apparent weight is plus, when I bring it to this side, it becomes minus. So then I have Upthrust equals real weight minus apparent weight. And real weight, I know it's 17. Apparent weight is 12. So 17 minus 12, I get 5 newtons. That's the upthrust. Is that clear, Lamai? Is this clear to you? Others? Okay. So I think you put the topic. Let me put a small point here. All right. So write this sentence and then draw this diagram. Make it fast. Huh? Make it fast. Okay, am I done? Done writing? Give me a thumbs up if you have finished. Others? Okay, Senudi, Sasheli? Okay, so now we'll talk a little bit more about upthrust. Like we'll try to understand this a bit more. And there is something called Archimedes principle. Okay, so I will tell you the story of Archimedes in a bit. Once we finish discussing this part, I will tell you the like a little bit of a story time, right? What happened with Archimedes and why is he so famous? Okay, so then we might okay. මේකට setup එකේ picture I will take it straight away from the textbook because no point really drawing. Okay. I will explain this setup. What happens here is that there is one object here. Okay. මෙතන මේ එක වගේ objects දෙකක් එකට stick කරලා තියෙන්නේ. So like this. Okay, so so this is considered as one full object. So then බලන්න මේ A කියන instance එකේ obviously a spring balance is there and this object is not immersed into the liquid, right? It's only touching the surface. It's not immersed to the liquid. හරිද? So when it's not immersed, මෙතන මට reading එක එනවා 1.2 newtons in the spring balance. Okay. And it's not immersed, huh? It's not immersed. It's only lightly touching the water surface only. Yeah, immersed වෙලා නැහැ. Now what happens here is that I immerse the object only half. මේ බලන්න half වෙනකන් විතරයි මම immerse කරලා තියෙන්නේ. එතකොට දැන් මෙතන මේ මෙන්න මෙතන mouth එක ගාවටම water fill කරලානේ තියෙන්නේ. Here mouth එක ගාවටම water fill කරලා තියෙන්නේ. But in this instance, the object didn't immerse into the water. It only touched the water surface. So water didn't leak through. But now here, half of the object is immersed. එතකොට දැන් මෙතන ඉස්සර mouth එක ගාවටම වතුර තිබ්බානේ. මම object එක ඇතුළට දාපු ගමන්ම වතුර ටිකක් මෙව leak වෙලා මේකට වැටෙනවා. Okay. So here the spring balance reading is 0.9 newtons, right? 0.9 newtons. Then in the next instance, what I'm going to do is I'm going to immerse it fully into the water. The whole object, I'm going to immerse it to the water. හැබැයි මේ water surface එක ළඟම තමයි තියන් ඉන්නේ. දැන් එතකොට දැන් ඉස්සල භාගයෙන් immerse උනේ දැන් fully immerse වෙනවනේ. එතකොට තව water ටිකක් මේක through මේකට leak වෙනවා. Now if I look at the spring balance reading, it would show 0.6 newtons. Now here, I have already put the entire object into the water. Then water ඇතුලේ එහාට මෙහාට move වුණාට වැඩිපුර ආයේ වතුර මේකට යන්නේ නැහැ. Because now it's already immersed no. Then ඇතුලේ එහාට මෙහාට move කරා කියලා water මෙතනින් leak වෙන්නේ නැහැ. Here also the spring balance reading will be 0.6 newtons. Spring balance reading is it clear? We'll go step by step. Is the spring balance reading clear? Anya, Sasheli? Sasheli? Okay. Then මම තව වැඩක් කරනවා. මොකද්ද? මම මේ displace වෙන water ටික measure කරනවා. ඒකේ weight එකත් මම වෙනම ගන්නවා. Right, දැන් බලන්න මෙතන here දැන් ඒතර beak එකේ weight එකෙන් අඩු කරලා තමයි ගන්න ඕනේ. now for an example මම මේකේ weight එක ගන්නවා නම් ඒකේ full weight එක අරන් beak එකේ weight එක අඩු කරාම subtract කරාම තමයි මට මේ water ටිකේ weight එක එන්නේ. So I'm only getting the weight of the water only, not the beaker. So here there's a beaker, but there's no water, right? So here weight of the displaced water is 0 newtons, right? Because no water was displaced. Okay. Then here, if you look at this, metana, the weight of the displaced water, only the water, that is 0.3 newtons. All right. Then here, Now more water was displaced now. Now the weight of the displaced water is 0.6 newtons. Now here දැන් කොහමද ඇතුළට move කර ඇතුළට දාගත්තට පස්සේ ඇතුලේ හැරම move කරා කියලා වැඩිපුර වතුර leak වෙන්නේ නැහැ. So මෙතන 0.6 now here also it will be 0.6. That is the weight of the displaced water. Okay. Up to that point, is that part clear to you? Others? Now let's talk about the next step. Here we learned something called upthrust equals real weight minus apparent weight. Then මෙතන upthrust equals real weight is 1.2 newtons. මෙයාම තාම වතුර ඇතුළට දැම්මේ නෑනේ. වතුර ඇතුළට දැම්මේ නැත්නම් එයාට තාම upthrust එකක් දැනෙන්නේ නෑ. වතුරට immerse කරාට පස්සේ තමයි water වලින් upthrust එක දෙන්නේ. මෙයා වතුර ඇතුළට දාලා නෑ. So there is no upthrust. Upthrust is 0. Okay. Here, if you look at this one, we know upthrust is real weight minus apparent weight. May objects dekhe real weight එක තමයි මෙතන එන්නේ නේ because it's outside now. So real weight is 1.2 newton. ඔන්න මම මෙතන ලියන්න real weight. So we already know the real weight. So real weight is 1.2 newtons. Apparent weight is what is shown here. We know it's not the real weight, but the real weight is 1.2. This is just apparent weight. So that is 0.9 newtons. So 1.2 newtons minus 0.9 newtons, we get 0.3 newtons. That means upthrust here is 0.3 newtons. Now let's look at this one. Upthrust is real weight minus apparent weight. Now, real weight doesn't change. Real weight is still 1.2 newtons because that was the weight when it's outside the water. 1.2 newtons. Apparent weight is the weight that is being read in the spring balance now. It's 0.6 newtons. 1.2 newtons minus 0.6 newtons, we get this upthrust as 0.6 newtons here. Then in D instance, upthrust equals again real weight minus apparent weight. Real weight, we already know it doesn't change. It's 1.2 newtons. Sorry. 1.2 newtons. Here also apparent weight is 0.6 newtons. So 1.2 minus 0.6 will be 0.6 newtons. That is the upthrust. Okay. Up to that point, is it clear? Anya? Okay. So, then mum make a table you will see why. Right? On I will create a small table and I will put all of these into a table. Give me 1 second. Huh? Okay, sorry Lamai. So let's create a small table. Like this. Okay. You will see why. And okay. ඔන්න බානවා මොකද කරන්න කියලා මේකේ මම දානවා the stage of the and all right, so here the stage of the object, right? මෙතන මම දානවා here we'll put spring balance reading. Reading of spring balance reading. And මෙතන අපි දාමු weight of the displaced water. And in the last column, we put upthrust. දැන් ඔක්කොම අපිට values ටික තියෙනවා ළමයි, so it's easy, right? Okay. So first stage එක තමයි A. A කියන stage එක. What happens in A? The object is near the water surface, right? Object is near the water surface. තාම හැබැයි water ඇතුළට දාලා නැහැ. See, look at A. Object is not inside the water. It's still outside. Okay. So spring balance reading, we can see here it's 1.2 newtons. Weight of the displaced water here in A, no water is displaced, right? So here it's 0 newtons. And we also calculated upthrust now. So මෙතන calculate කරන්න දෙයක් නැහැ. මොකද තාම වතුර ඇතුළට දාලා නැහැනේ. So no upthrust here. So upthrust is also 0. Now let's talk about instance B. B වල මොකද වෙලා තියෙන්නේ? Now metal cube or object is partially immersed, or we call it partially submerged, right? මේ භාගයයිනේ වෙලා තියෙන්නේ. So object is partially submerged in water. Spring balance එකේ reading එක 0.9 newtons. Displaced water 0.3 newtons. Upthrust we calculated, that is also 0.3 newtons. Then instance C. Instance C එකේ the object is fully immersed, right? Fully immersed හැබැයි water surface එක ළඟම ඉන්නේ. Fully immersed වෙලා water surface එක ළඟම ඉන්නවා. So object is fully immersed and near the water surface. Spring balance reading is 0.6 newtons. Weight of the displaced water is also 0.6 newtons. Upthrust I calculated, that is also 0.6 newtons. Then D, here also object is fully immersed. C වගේම තමයි object is fully immersed or submerged, whatever. And now it's a little below the water surface, right? And is below the water surface. There also you can get the spring balance reading here 0.6. Weight of the displaced water is 0.6 and upthrust is also 0.6. All right. Is this clear, ළමයි? මම ලියපු ටික clear ද ඔයගලන්ට? The numbers, is it clear? ළමයි? Others? Okay. Now what I want you all to realize is that there's something special here. බලන්න හැම වෙලේම weight of the displaced water here is 0.3, upthrust is also 0.3. Weight of the displaced water is 0.6, upthrust is also 0.6. Weight of the displaced water is 0.6, upthrust is 0.6. Here weight of the displaced water is 0, upthrust is also 0. Always, lamai, the upthrust or weight of displaced water is equal to upthrust. And that is something very special. Make a tamai Archimedes QA. This is what Archimedes said. Archimedes said, always when an object is near the water surface, but when an object is partially or fully immersed in a liquid, upthrust acting on that object is equal to the weight of the liquid displaced. Weight of the displaced liquid. Archimedes QA. So do you understand that these are equal in all these instances? Weight of the displaced water and upthrust are equal. That is something special. Okay. Can you all up make it a topic activity? quickly copy this number and make it fast. So that diagram එක draw කරන්න ඕනේ. So it's going to take a little bit more time, but quickly do it. Diagram එක draw කරලා table එක අන්න. Make it fast.
Miss, can you scroll down a bit, please?
Yes. Yeah. Perahara is, I heard that it's one of the best experiences. The only problem is that it's a little crowded, no, Perahara? So I don't think I'll be in Kandy until that long. But we've actually thinking maybe we should send our parents because they will really like the Perahara experience. I know that it's one of a kind experience. The only problem is that it's a little crowded. I'm not sure if I will have free days those during that period, but I think my our parents will might they might come to the Perahara. Uh, when is it starting? Oh, and when is it ending? On the Poe day, right? Okay, Lama, I think this is enough time. Did you all finish writing? Give me a thumbs up if you did. Or do you all need like one extra minute? Give me a thumbs up if you have finished. Or do you all need more time? Okay, I'll give you 2 more minutes, huh? Make it fast. All right, Lamai. So, yes, Archimedes principle is what we're going to be talking, right? So, Archimedes principle like a gattahama. So, you may have already heard of Archimedes before. So, Archimedes was a very interesting guy. Yeah, tama pressure, especially aptras gan ya loku discovery ka kara. That is why to honor him, we call this principle the Archimedes principle. So, what happened was that Archimedes was a guy in Greece. He was a Greek mathematician. He was very good at mathematics. He was also very good at physics, and he was also very good studies karne ke kya, right? Mathematics, physics, and like geometry, which is still mathematics, and also like apsaras can him good discoveries kara, as I said. And also he was so good that ekaloya mein war වලට එහෙම එයා ගොඩක් war machines එහෙම හදලා තියෙනවා, right? ඔය defensive එක machines හදලා තියෙනවා for Greece. So anyways, I think he was in Sicily or මොකක් හරි ඒ පැත්ත I can't exactly remember much about this story, but I think he lived in Sicily. And once the king of Sicily, now the king knew Archimedes and he was a genius and all that. And king ඔන්න මේ එක මිනිස්සෙකුට දුන්නාලු එයාගේ crown එක හදන්න, right? To make the crown with real gold with like very delicate artworks and all that. So දුන්නට පස්සේ what has happened is that okay, so this person has made the crown. ඊට පස්සේ king crown එක ගත්තට පස්සේ king was a little suspicious. King බැලුවා මේක ඇත්ත දැන් මම දීපු gold වලින්ම හැදුවද නැත්නම් එයා ඒ gold ටිකක් හොරකම් කරලා වෙන metal එකක mix කරලා හැදුවද එහෙම කියලා king ට පොඩ්ඩක් suspicious. So දැන් කින්ට හොයාගන්න විදියක් නෑනේ මේක because not like he can melt the crown එක melt කරන්න බෑ because the crown it's very beautiful or හරි delicate විදිහ ලස්සනට හදලා තියෙන crown එක. So he didn't want to melt it and find whether this is actual gold or whether the metals are mixed. So he thought දැන් මොකද කරන්න කියලා එයාට මතක වුණා Archimedes is a smart guy no. So Archimedes ට කියලා බැලුවා නම් හරි කියලා. So the king of Sicily he called Archimedes. Right? Archimedes කියලා කිව්වා Archimedes I have a problem. So I got this crown made by some person, but I'm not sure if he used real gold or if he just mixed gold with metal. So Archimedes okay කියලා ගන්නවා. දැන් Archimedes ට ප්‍රශ්නයක් කොහොමද මේක කරන්නේ because he can't melt the crown and check no. So crown එක තියෙන විදියටම තියලා තමයි යා check කරන්න ඕනේ. So ඇත්තටම මේ කතාවේ ඕගලන්ට confusing part එකක් තියෙනවා because you don't know how to link this with upthrust. Right upthrust එකයි මේ කොහොමද මේක metal mix කරලාද නැද්ද කියලා ඒක link කරන්න ඕගලන් දන්නේ නැහැ. It's a different mathematics with like density and all that. But anyways, what happened was so Archimedes spent days and weeks trying to figure this out. ඒත් එයාට මුකුත්ම හොයාගන්න බැරි වුණා. ඊට පස්සේ පොඩ්ඩක් ඒක අතහැරලා දාලා so he went to like take a bath. Right එයාගේ ගෙදර bath tub එකේ වතුර පුරවලා he took off all his clothes and he immersed himself in the in the bathtub. So one thing that he noticed was that when he sunk into the bathtub, then normally අපි උනත් හිතා බලන්න bathtub එකේ වතුර පුරවලා අපි bathtub එකට බහිනකොට වතුර ටික එළියට යනවානේ. ඒ මොකද දැන් bathtub එක full වතුර වලින් පිරලා තියෙද්දි මම බැස්සහම දැන් මම බහිනවා කියන්නේ මගේ body එකට space එක හදන්න එපා. ඒතර ඒ space එකට relevant වතුර ප්‍රමාණයක් එළියට යනවා. That's normal. Even here you see if you look at this one as soon as the object is immersed දැන් මේ කට ළඟට වතුර තිබ්බා. object එක immerse වෙච්ච ගාම ඒකට හරියන volume එකක් වතුර displace වෙනවා. එළියට යනවා. Same thing with the bathtub. So Archimedes student එක දිහා බලන් හිටියා. And then it was a light bulb moment for him. He quickly realized something. That is when he discovered upthrust. So දැන් අහන්න එපා කොහොමද upthrust with crown එකේ density එකයි connect කරන්න කියලා because that is a different concept altogether. And that's a different concept which we are not going to be discussing. But anyhow අන්න එතනදි තමයි Archimedes upthrust තේරුනේ. He instantly understood upthrust and ඒකත් එක්කම යාට තේරුණා මට මේ concept එක use කරලා crown එක real gold mix කරපු gold කියලා හොයාගන්න පුළුවන් කියලා ඒ වෙලේ තේරුණා. He was so delighted because he spent days and weeks on this and couldn't find anything no. And he also didn't have anything to tell to the king. And then when this happened, he was very happy. He was very delighted. එයා එකපාරටම bathtub එකේ නැගිටලා Eureka කියලා කෑ ගහලා ඒ town එක වටේ දිව්වලු and he forgot to even dress himself up. He was already like he took off all his clothes. So he was naked when he got into the bathtub. එයාරක realize කරා මේ සතුටට ඇඳුම් ඇඳ ගන්නත් අමතක වෙලා එයා ඒ town එක වටේ දිව්වලු Eureka කියලා කෑ ගගා. Eureka means I found it. I discovered it. That's what it means. So අර අන්තිම part එක whether he actually ran around naked I don't know whether this is true or not because history කියන එක මිනිස්සුනේ ලියන්නේ so maybe it's true maybe it's not but apparently that is what happened. So that's the story of Archimedes. We call it like the famous bathtub story, right, of Archimedes. That he's quite famous because of that. But not just because of that, but I told you he's very much a genius, right? Not just mathematics, but also physics. And also then he combined mathematics and physics in many ways. Monkey were vowel tone there was this war between Greece and Rome. Yeah, I think so. කොහමද මොකද war එකක එහෙම යා ගොඩක් ඔය එක war equipment එක defensive එක mechanisms එහෙම ගොඩක් හදලා තියෙනවා. He was a genius and apparently war කාලෙම තමයි යා මැරිලා තියෙන්නේ. So anyways yeah so how Archimedes is relevant to this is like that. ඔය මේ object එක immerse කරද්දි water එළියට පයින්නවා කියන එකම තමයි යාර bathtub එකේ realize කරපු කතාව. ඒකෙන් තමයි එයා upthrust ගැන ලොකු realization එකක් කරනවා. And that realization only we are still using. So to honor Archimedes, we call the principle that he introduced as Archimedes principle. So we can write the Archimedes principle. I think that would save us some. Excuse me. That would save us some time. So fluid can be any liquid, right? This is the Archimedes principle. Can you quickly write this down? All right. Now we'll move to the last activity of the lesson, right? Again, this is quite, excuse me. Again, this is quite an important activity. So once pressure is over, we have to do changes in matter. I don't think I sent a note for changes in matter, right? 1 second. Changes in matter. I think it's this. Yeah. All right, Lamai, for changes in matter, we have the note. Mamme damma mevanna ukamat nattang amataka venawa. I will forward it to the group. Lesson 16, changes in matter. Please take a printout before the next class. Okay. So namatak vena khali my group ekata damma. So do take a printout and come before you come to the next class. එතකොට ඒක තමයි අපි next week කරන්නේ. Okay. So our next activity is, all right. When I take another like a big tank of water, or you can use any liquid. Water can lacing access and also we are very familiar with water, so that's why we are using water. But you can use whatever liquid you want. So I'm taking this tank of water. It's filled with water. So have you all noticed something? Now, if you take like a piece of wood, you know a piece of wood floats on water. හැබැයි අපි ලී කෑල්ලක් වතුරට මෙහෙම උඩින් මෙහෙම අතෑරය කියලා හිතන්න. අතෑරපු ගමන් එයා එකපාරටම මෙහෙම වතුරට වැටිලා වතුර ඇතුළට ගිහිල්ලා තමයි ආයෙ උඩට එන්නේ. ඊට පස්සේ තමයි පාවෙන්නේ. Anybody who has noticed this? Or let's say like ගොඩාක් ඇතුළට යන්නේ නැහැ, but as soon as you put an object like a floating object like wood or නිකන් light plastic වගේ ගත්තොත් එimhe වතුරට අතෑරපු ගමන් එයා මෙහෙම වතුරට වැටිලා වතුර ඇතුළට පොඩ්ඩක් ගිහිල්ලා then ආයෙ උඩට ආවිලා ඊට පස්සේ තමයි පාවි පාවි ඉන්නේ. නැතෝ කෙලියම ස්මූත්ලි ගිහලා තිබ්බොත් එයා පාවි පාවි ඉඳී, but what I mean is when you drop an object, it falls onto the water, goes into the water, and then comes up and then floats. So keeping that in mind, okay. So now we have a few objects, right? Okay, first object එක තමයි I will label this as A. I have attached a spring balance, right? So outside එළියේ තියෙනකොට මෙයාගේ weight එක 1.1 newtons. 1.1 newtons. So what I'm going to do is I'm gonna immerse this to this liquid, right? When I immerse, what happens is that lamai, I'll make this a little smaller. Meya mehema දාපු ගමන්ම මුලින් පොඩ වතුර ඇතුලට ගිහලා ඊට පස්සේ මෙහෙම ඇවිල්ලා පාවි පාවි ඉන්නවා. So this is a floating object. Okay. Then I'm going to take another object, that is, let's say object B. මෙයාවත් මම එළියේ මුලින්ම real weight එක measure කරනවා using a spring balance. So මෙයාගේ real weight එක 1.8 newtons. These are all example values only. ඊට පස්සේ මම මොකද කරන්නේ? එයාවත් ගිහලා immerse කරනවා. immerse කරාම එයා මේ මැද හරියට වගේ යනවා. හැබැයි පාවි වතුර ඇතුලේ but පාවි පාවි ඉන්නේ. ගිලෙන්නේ නැහැ. It's not sunken. වතුර ඇතුලේ එයා පාවි පාවි ඉන්නවා. Then I have another object C. එයාටත් මම spring balance එකක් දානවා. එයාටත් මම spring balance එකක් දැම්මම එයාගේ weight එක පෙන්වනවා 2.4 newtons. And then එයාවත් මම මෙහෙම water එකේ immerse කරනවා. එයාව immerse කරාම එයා මොකද වෙන්නේ? කෙලින්ම පල්ලෙහාට ගිහිල්ලා එයා it sinks. කෙලින්ම sink වෙනවා. පල්ලෙහාටම ගිහිල්ලා මෙහෙම sink වෙනවා. This is C. Now we already know their real weights, right? මේ real weights I already know because earlier මම එළියේ තියදී හැමෝගෙම weight එක calculate කරා. So real weight I already know, no problem. Now once you immerse it, I can get the apparent weight. Apparent weight කියන්නේ මෙයා immerse කරලා පස්සේ පෙන්වන weight එක. Now there's something very surprising. What is it? ඒව immerse කරාම එයාගේ apparent weight එක පෙන්වන්නේ මෙතන 0. It's just 0. It's real weight it was 1.1 newtons, right? But when I immerse it, you know, A will partially submerge and float. And its weight is, apparent weight is 0 newtons. Okay, and then B. B got to 1.8 newtons the real weight. When I put into water, it fully submerged. Completely gilenawa gilila ya pavi no water athule. Yeah, apparent weight that is also 0 newtons. That is also 0 newtons. Then if you look at C, C real weight is 2.4 newtons, right? And then what I'm going to do is I'm going to immerse this, so it went down and it sunk. So may I give parent weight 0.5 newton scale. So this is a very weird result, right? They all have 1.1 newtons, 1.8 newtons, 2.4 newtons. Likewise, they all have real weights, but A and B then again apparent weight is 0. C has an apparent weight of 0.5 newtons. So that's a little bit of a like surprising result. Then what I mean, I can calculate upthrust now, so I will calculate upthrust. බලමුකෝ මොකක්ද මේකේ වෙන්නේ කියලා. A ගත්තොත් එහෙම upthrust we know that is real weight minus apparent weight. A වල real weight එක අපි එළියෙ මෙම calculate කරා 1.1 newtons. Minus apparent weight I got here 0 newtons. So 1.1 newtons minus 0 newtons would be 1.1 newtons. That means upthrust is 1.1 newtons. Okay, on A වල upthrust එක 1.1 newtons. All right. Now let's check B. What happens to B? Again, we use upthrust is real weight minus apparent weight. B get real weight like 1.8 newtons. Apparent weight we got here 0 newtons. එතකොට අපිට එනවා 1.8 newtons minus 0 newtons is still 1.8 newtons. So that is upthrust of B. Okay. Now let's check for C. Same story. Upthrust equals real weight minus apparent weight. So real weight is 2.4 newtons. That is what I got when it's outside. Apparent weight I got here 0.5 newtons. So upthrust we get 2.4 newtons minus 0.5 newtons would be 1.9 newtons. So this is the upthrust that I'm getting. Okay. So, all right. A කියන්නේ දැන් බලන්න මේ ABC තුන් දෙනාගේ real weight එක I know how to mark, right? So I will mark the real weight. A වල real weight එක 1.1 newton, B වල 1.8 newton, C 2.4. Weight එක, right? 1.1. මෙයාගේ 1.8, මෙයාගේ 2.4. තුන් දෙනාටම upthrust තියෙනවානේ. මෙයාගේ upthrust එක A වල upthrust එක we calculated 1.1 newtons. B වල upthrust එක I calculated it's 1.8 newtons. C වල upthrust එක I calculated 1.9 newtons, right? So they all have weight and upthrust. Up to this point, is it clear? Up to this point, is it clear? Okay. So A වල A කොහොමද ඉන්නේ? A ඉන්නේ මම එකත් මෙතන දාන්නම් so that we have it's very clear for us. A is partially submerged and floating. B is partially submerged and භාගයට ගිලිලා it's floating. B is fully submerged and floating. C is කෙලින්ම sunk, right? Now we are going to talk about what exactly happened here, right? Let's talk about that. So මුලින්ම A වගේ object එකක් ගත්තොත්. ඇයි A partially submerged වෙලා තියෙන්නේ? Right? Before we talk about that, can you copy this down? Because otherwise it will be a little too much. So first copy this down and then I will explain what exactly happens here. Make it fast. Quickly. Activity කියලා නිකන් දාගත්තාම ඇති. Quickly, huh? Done writing, Lamai? Have you all finished writing? Others? All right. So since our time is up, we'll wrap up. We just have the explanations of this, which would not take too long. And then we have to also talk about the hydrometer. Then we'll be done. So next week, we are starting changes in matter. Yeah, it's one of the longest lessons in chemistry. And changes in matter is a lesson on which most other lessons are dependent on. So it's very important we learn changes in matter, correct? A lesson එකට කලින් lessons වල knowledge එක ඕනේ. Structure of matter, the third chemistry lesson. ඊට පස්සේ quantification ටිකක් ඕනේ, seventh lesson. Yeah, mostly those. So A lessons එක චුට්ටක් revise කරන් එන next week එනකොට, and also please do bring the printout. Then it's very easy. It will save us a lot of time, right? Printout එක තියෙද්දි කරනකොට හරියම ගොඩක් time save වෙනවා. Okay? So yeah, I think that's pretty much it. Is everything we did today clear, Lamba? Any questions? Give me a thumbs up if it's clear. If you have questions, you can ask. Anya? All right. Then let's wrap up, Lamai. Let's see each other next week. By the way, it's your school holidays, so I'm thinking of doing a few extra classes. I will put a poll for some available slots, and then we'll schedule that way. Otherwise, we have the class next week, which is 18. Okay? All right. Then see you next week, Lamai. Good night.
Good night, teacher. Thank you, teacher.
Night.